So each year at this conference, NASA recognizes individuals and organizations for scientific and technological investigations that contribute to innovative utilization of the ISS. We at AAS are happy to play a small part in presenting these awards and making them possible. So I'd like to ask Dr. Costello to come back up. Once again, he's ISS Chief Scientist at NASA, and Dr. Mike Roberts, Deputy Chief Scientist at the ISS National Labs, to join me on stage to present the 2019 NASA International Space Station Research Awards. Gentlemen.
Oh, there you go. There's the music. Thank you, Jim. All right, this is one of my favorite sections of the conference, getting together to really award and appreciate those people who've done research or been innovators in the field of ISS research. This is an opportunity to really kind of look across the gamut of people that we have doing research and helping support the platform and say thank you for making everybody who follows after you just a little bit more successful. We look at across all of the fields and we select researchers and innovators from those fields. So the International Space Station has been a beacon for space-based science, technology, and human innovation for almost 2 decades. The ISS Research and Development Conference Awards gives us the opportunity to honor the people behind the science, pioneers in their field who continue to make breakthroughs in research on the ISS, and paving the way for future human exploration. This year's researchers were selected for pushing the boundaries of space-based research in 2 categories: compelling results, leading projects that have produced promising results from the preceding year's publications, and innovation, those who utilize the space station to effectively pioneer a new frontier in space-based science in the name of commercial expansion and exploration beyond low Earth orbit. I'll be announcing the names for each award, and while they make their way up to the front, I'm going to tell you a little bit about their research. We'll have time for a few photos before moving on. So with that, I'd like to announce our first award. Our first award goes to the NICER Investigation Team for compelling results in the physical sciences. Team lead, Dr. Keith Gendreau, please come to the stage. The NICER team dedicated years exploring our universe's most dense objects, neutron stars, with the help of the Neutron Star Interior Composition Explorer, or NICER. Since 2017, NICER has made a name for itself in the world of astrophysics, with observations of rapidly spinning X-ray pulsars and corona contractions of stellar black holes. Featured in the cover articles of Nature and Scientific American, NICER's extensive high-precision measurements and collaborations with other space-based telescopes, such as MAXI, XMM Newton, and Chandra, have offered unparalleled insight into the nature of neutron stars, black holes, and other X-ray astrophysics phenomena. The NICER team is also taking steps towards utilizing NICER's X-ray detecting capabilities for more than just stars, but also for understanding exoplanet atmospheres. Congratulations to the NICER investigative team for helping to describe some of our universe's secrets.
Congratulations.
Congratulations, Steve.
Congratulations. Head off that way, grab your box.
It's going to be tough to follow someone called NICER, but we'll do our best here. The next award goes to Dr. Alessandro Bertoni from the Houston Methodist Research Institute for compelling results in biology and medicine. Dr. Bertoni, can you please come to the stage? Microgravity affects the musculoskeletal system in many ways. Dr. Bertoni and his team have contributed to a series of ISS US National Lab projects involving nanofluidics and the development of technologies that will and are today revolutionizing drug delivery approaches. One day, these methods will benefit astronauts experiencing microgravity-induced muscle loss on Mars and beyond. If we want to get into specifics, you should know that they have conducted rodent research missions to demonstrate the effectiveness of an implantable nanochannel drug delivery system that mitigates microgravity-induced muscular atrophy. This research, however, not only benefits the astronaut corps, it also applies to those of us here on Earth struggling with conditions that compromise the health of our skeletal and muscular systems, including immobilization, cancer, and the effects of aging, which I'm feeling at an accelerated rate in this, the last day of our conference. Congratulations, Dr. Bertoni, and your entire Rodent Research 6 team.
Congratulations.
All right. Our next award is for compelling results in technology development and demonstration, and it goes to Dr. Mohammed Qasimi from Case Western Reserve University. Dr. Qasimi, please make your way to the front. Dr. Qasimi's team conducted a series of microgravity and ground-based experiments that investigated tank pressurization and pressure control of volatile fluids when exposed to heat transfer and other space environmental conditions. Zero boil-off tank produced experimental and numerical models that will be used to create a foundation for the development of low-risk and cost-efficient cryogenic propellant storage systems that meet the demand for future long-term space expeditions. Congratulations, Dr. Qasimi. Congratulations. The next award is Compelling Results in Plant Science and goes to a team of researchers who demonstrated that, similar to animals, plants possess complex signaling networks that trigger defense mechanisms in responses to stresses. It goes to Dr. Simon Gilroy from the University of Wisconsin-Madison. Simon, please come up to the stage. Okay.
Congratulations.
Thank you.
Simon and his team administered herbivorous and mechanical damage on a model plant, Arabidopsis, and monitored the systemic response at both the damaged site and in the undamaged neighboring leaves. What they noticed was that glutamate functions as a wound signal. Stress from the damage jumpstarts the release of glutamate, and its receptor-like ion channels trigger an increase in intracellular calcium ion concentration, alerting neighboring leaves of another's untimely fate, and triggering defense mechanisms. Understanding how plants react to stresses can help us select and improve those that can handle the demands associated with long-duration spaceflight. Thank you, Dr. Gilroy's team.
Thank you very much.
Sarah, nice. Thank you.
And this isn't on the script, but I'll add it anyway. Dr. Gilroy's team is also working on the ISS National Lab funded by the Target Challenge. They're also exploring ways to increase water use efficiency in cotton plants. So when you're thinking about space, it has multiple applications. Our next award goes to Dr. James Goodman from High Speed Computing for his computing results in earth science and remote sensing. Dr. Goodman, please make your way to the stage. With more advanced remote sensing and satellite technologies on the rise, comes a concomitant increase in demand for computer systems that can handle this wealth of information. Dr. Goodman took the initiative to develop a commercially available cloud computing web application that uses data from the hyperspectral imager for the coastal ocean, known to those of us who like acronyms as HYCO, to deliver low Earth orbit imagery analysis that meets the specific needs of user demands. After being presented to Harris Corporation, this single product soon became 3 fully operational systems ready to be plucked off the shelf. Congratulations, Dr. Goodman.
Congratulations again. You bet.
Thank you.
The next award goes to someone who should be familiar to the audience, Dr. Dmitry Starbov from FOMS Incorporated, for compelling results in commercialization and non-government utilization. Dr. Starbov, could you please return to the stage? Z-Bland is an optical fiber that has proven itself superior to traditional silica-based fibers. Yet all it takes is the presence of gravity and moisture during the manufacturing process to degrade the capabilities of this fiber and hinder its performance, but not in microgravity. FOMS built the space facility for orbital remote manufacturing with that in mind. This is a platform built for the express purpose of optical fiber production in microgravity. In space, Z-Bland can be produced with significantly fewer growth imperfections, resulting in high-quality fibers that can improve the cost and efficiency of communication systems here on Earth. This is yet another example of how we can utilize the International Space Station to benefit the commercial industry. Congratulations, Dmitry. Our first award in the innovation category goes to Dr. Nicole Wagner from Lamb Division for innovation in biology and medicine. Dr. Wagner, can you please come to the stage? Millions of people suffer from retinal degenerative diseases. The most common types are age-related macular degeneration and retinitis pigmentosa. There are currently no cures for these conditions, only treatments that delay their progression. Dr. Wagner and Lamb Division have developed an alternative approach that doesn't involve bulky battery packs and limited improvement in the condition of these patients, but rather a first-of-its-kind, first-in-class, light-activated protein-based retinal implant. Taking advantage of the microgravity environment to suppress the negative effects of sedimentation during the manufacturing process, Lamb Division believes preparing these implants in microgravity will be faster and thus will facilitate their path to commercialization. Congratulations to Dr. Wagner and the Lamb Division team.
Okay. This one I get to add a little bit of personal congratulations. The next award goes to Christy Cox from NASA's Human Exploration and Operations Mission Directorate for innovation in commercialization and non-government utilization. Christy, please come to the stage. As the ISS Division Utilization and Commercialization Lead, Christy collaborated with a multitude of stakeholders to establish NASA's now in effect low Earth orbit strategic commercialization plan. Reflecting the agency's new vision for low Earth orbit, commercialization of low Earth orbit means that NASA will be one of many customers as it turns its attention and resources to deep space exploration under the Artemis program. Without Christy's innovative mindset and leadership skills, this achievement that marks the beginning of an era would not be possible. Congratulations, Christy Cox. Our next award goes to Colleen King from NASA's ISS Procurement Office for Innovation in Finance. Colleen King, please come up to the stage. When it comes to government contracting, Colleen knows her stuff. She continues to facilitate emerging markets in low Earth orbit, all the while pioneering acquisition strategies that best satisfy the demands of the commercial space sector and NASA's interests. Her contributions have economically enriched the emerging commercial presence in low Earth orbit. And we have no doubt that with her help, it will continue to thrive. Congratulations, Colleen. The next award is for innovation in biology and medicine. And it goes to a team of scientists who developed a unique rodent research facility on the ISS that intends to lead the charge in research behind gravitational effects on mammals in space. JAXA's Kibo Mouse Habitat Unit Mission Team, Dr. Masaki Shirakawa, please come up to the stage. The Multiple Artificial Gravity Research System, or MARS, provides on-orbit artificial 1G capabilities through centrifuge, allowing for precise gravitational comparisons and studies involving genetically modified or disease model mice. MARS also contributed to studying the mechanisms behind visual impairment through a NASA-JAXA collaboration effort, and recently demonstrated for the first time low-gravity habitation of mice. MARS is a pioneering platform that represents utilizing the ISS to its fullest capabilities and getting international partners involved to maximize research outcomes. Congratulations to the Kibo Mouse Habitat Unit Mission Team.
Our final award goes to Dr. Ilya Guza from the University of Wisconsin-Madison for innovation and STEM engagement. Unfortunately, Dr. Guza was unable to be here to receive the award today. Just checking. Dr. Guza created a program that gives middle school and high school students the opportunity to fly their crystal growth experiments to the International Space Station. Space Crystal Prize is unique because rather than the investigator, the students drive the development of the experiment as lead scientists and hardware developers. This program gives students a strong sense of ownership and is recognized for being a significant influence on their decisions regarding future careers. Congratulations, Dr. Guza.
With that, we'll hand it back to Jim.
Yep, you're up, sir.
Great.
Thank
And
you to all
I've
of
just
our
got,
winners.
what's that?
Thank you to all of our winners.
Absolutely, thank you. And I've just got a couple more real quick ones. The student poster contest. So the posters that were down in the marketplace and had people presenting their posters. So these are the AAS student poster contest winners. So when I call your names, I believe you're here, please come on up. For our secondary or high school category, our winner is Sophia Chen from Lakeside High School in Seattle. She couldn't be here, unfortunately, but accepting for her are a couple of folks. RT, hopefully I don't butcher this too bad, Vinaya Kumar and Rebecca Lee. There you go. Congratulations. Excellent. Great, thank you. Thank you, congratulations, great work. And our graduate and undergraduate category, the winners are Paul Burke and Daniel Varnum Lowry, both graduate students at Texas A&M. Gentlemen, please come on up. Just do one representative one. Come on over. Congratulations. Thank you. Absolutely, congratulations. You bet. Great, thanks very much. And once again, I encourage you guys, I encourage everybody to go down there to the marketplace and take a look at these posters. It's just fantastic work by all of them. So please do that.